Hi guys, and welcome to today's video. In this video I'm going to show you how we can implement a linked list, and we're going to start off simple. So I already have some kind of implementation here that I have created before that video, but we're going to add the add method here, which will be adding a new node, and we're going to be pushing it in the end of the linked list. I have also created the find kth element from the last node, and also I have this remove duplicates function and this print list function or method. Now in this video I decided to make this a series just so we don't end up with one huge and very long video. So now in this video I'm only going to show you how we can implement the linked list class, and then I'm also going to show you how we can implement the add method, and then I'll probably have another video where I'm discussing how to find a kth element and then how we can remove the duplicates, like for example having 4 fours or whatever the case might be. Alright, now let's start simple. Now as you can see here, what I have is in the structure I've got this new node, and this is a class that I have created. So what we will have to create is the linked list class and the node class. Now each node will be, so before I actually go any further, let me just show you really quickly what the linked list, just in case you might not know what it is. So that would be a simple linked list example, and that is no. So what really a linked list is a bunch of nodes, like this is a node, this is a node, everything is a node here, and it's kind of like an array list. However, sorry, not an array list, but an array. And unlike arrays, you cannot access a specific element from that linked list using an index. Like you can't say, for example, linked list and then 4, for example. That wouldn't give you what you would expect, like it would give you in an array. However, in order for you to get a single node from the linked list, you would have to loop through it, right? So that's one of the differences between linked lists and arrays. I mean, there are many more, but I'm not going to go into the differences here. But for now, I want you to know that linked list has nodes like this, and they're connected with each other. So this would be node, and the way that this node is connected to node 2, for example, right, to this node, is by saying node.next, right? And this node next is going to be equal to another node, and this another node happens to be the next node. That's why we have this next. And the last node has no as data in it, and the data in each node can be any single type that you can think of, right? So in our case, we're just going to stick with simple integers, just so it's simple to give it as an example, right? Now let's jump back to the implementation. Right, so let's create first the node, right? So let's create the node class. So let's say static class, because I just wanted to have everything in one single class. So static class, and we'll call it node. Node. And alright, now I want each node to have data, and I also want to have a next node. So that would be easy to do. Now I would say int data, that would be the data that is going to be stored within the node. And then I'm also going to have a node which I'm going to call next. And again, next points to the other node, to the next node in the linked list. And since this is a node type, we need to have this next initialized as a node type. Then let's create the constructor, which is node, and it's going to take data. And and I'm going to say this data, well, I mean, I don't need this, but well, I'm just going to say it. This data is equal to data. Alright, so we have initialized the data, so that's how we're going to invoke a node. So if you see in the pre-written class here, I say new node, and I just put whatever value or data I want in that specific node. And the next automatically is going to be no. So we only want to add a next node manually. And this is where our add function is going to take place in. That's what we'll be basically manipulating in our add function. Now let's create our, well, first before creating the main method, we want to create the linked list. So static class linked list. Now our linked list, well, I didn't say that, but in linked list also, the first element is called a head. And the last element is called a tail, right? So we want each linked list to have, well, not this, but we want it to have head, and we want it to have a tail, just like I showed you. And we want every single time we create a linked list, these head and tail to be set to no. So we want to have just a default constructor here for now, I think. And right, now let's create the add function. That's what we'll be changing. And this will be taken in node class, an instance node, instance of node class. And again, if I jump back here, you see we're saying new node, because now let me jump back to here. So suppose we have 1, 2, 3, and 4. What we want to do is, like, this is what we have right now. Now suppose we said add, and then we said 5. Then the new linked list, I mean the same linked list, but the new version of it would have we have 4 pointing to 5 instead of pointing to no. So this is the difference here when we say add. Right. So what do we really need to do? Well, first we need to have a base case, right? And that base case would be if head is equal to no. We want to make this node to be equal to the head, right? And we want it to be equal to the tail as well, because there won't be 2 elements, so the tail cannot be the last element. So it would make sense to make this node both a head and a tail. So we'll say head n and tail n. So again, this is just if linked list is empty. If it isn't empty, then what do we want to say? Well, first I want to create a temporary head of the current linked list. And the reason for that is I'm going to show you how we can iterate through a linked list. Now the way that we iterate through linked list is actually pretty simple. We say while temporary head is not, well, we want the next element, and I'll explain what that is not equal to no. We want to move the temporary head to the next element. What I really did here is, first I could say, right, instead of temporary head, I could say head, but then every single time we would be changing this head here. So every time it would be head 1, then head would be 2, and then head would be 3, right? But we don't want that. We don't want to change the head not to be equal to the first element, because as I said, head as a convention is equal to the first node in a linked list. So we don't want to be changing the actual value. Hence the need of creating a temporary head. So now we're, instead of changing the head, we're changing this temporary head, and when we say dot next, it goes to the next pointer, like this. And when does it stop? Well, until the next is pointing to no, like here, like 3 here is pointing to no, so it would stop right here, because now temporary head next would be equal to no. And remember, this temporary head starts from the head location. However, then it is changing, because we're saying dot next. So we're getting the next element and we're changing it to point to there. Hopefully that makes sense. Now what we really need to do, which will be actually the last part of the add function, is saying temporary head dot next to be equal to n, and that's it. Now what I said was if we come to this example now, this let me add the not that one but the pushes. So now here 4 is pointing to no, right? That's what dot next is for 4. However, then when we say add 5, we are saying make the 4 point to 5 or whatever n is, right? And make it point to there. And how do we make that? Well, we're saying temporary head dot next. So we're saying dot next in here actually. We're saying dot next. So it is going to be equal to what? Well, it's going to be equal to n. And what is n? Well, n, if we jump to the pre-written code, is some value. It's 4, for example. And automatically, if we jump back to the node constructor, you see that it only takes data, and node next is going to be no. It's going to be equal to no by default. So now this is going to point to no. So hopefully that makes sense. And then that's really it for the add function. So when we go, where's my closing bracket? There we go. So now let's create our main method. So public static void main. And then what do we say? Well, we need to create a linked list first. Linked list, and then let's just say linked list 1. And then we're just going to say new linked list, and our linked list didn't take any parameters, so just a default constructor. And then we can say add, and then let's say new node, right? We're creating a new instance of the node, and let's just pass it 1. There we go. Now we can just copy that a couple of times. So 2, 3. Now let's pass another 1 actually, just so I show you that it's not that it does accept duplicates, but in the next video we're going to remove the duplicates, which is a bit trickier, but you'll see. And then, well, we need another function which is going to be print list. Basically, it's going to be printing the list. And again, that's actually pretty simple. It's actually pretty similar. It's going to be public void print list, and the reason that we need to create it is because I can't show you what the actual data of the current linked list is. That's why we need it. And well, it's not going to take any parameters. And then we're going to say, well, again, we're just taking the temporary head, just so we need that for the loop that we're going to be initializing in a second. Well, I think that's it. And then we're saying wow, and then temporary head. Well, now we're not going to say dot next. We could say dot next, but we don't need it. We need to loop until the element is not no. So when we do loop in this case, it will go up until no, right? While it's not no. So I mean, it's not going to include no, it's going to go until there. So it's going to go actually until 5, not no, my bad. Because then when it goes to no, it's going to say, well, temporary head is no, so don't run that loop anymore. And what do we want to say? Well, we need to move the temporary head to the points to the next element by saying temporary head next. And right, and then what do we want to say? Well, actually, we want to print the data. So we're just saying system out print line what? We're saying temporary head dot data. Right? If we go back to the node class, you can see that it has data in it, and temporary head is of type node. It's starting from the beginning, and then we're switching, as you can see, I'm setting it to go to the next element. and then again we're just checking again whether that's no or not, and if it isn't, then print the data. And then we're saying L1 print list. Now this should give us the nodes, so let's just give it something like nodes, just so it's a bit more meaningful, so it makes more sense. Save that, run it. Let's see if we're actually getting that result. There we go. We see 1, 2, 3, 1, because these are the nodes that we have added here. And again, as you can see, it is adding the duplicates, but we're going to be removing them in the next video on that topic. And anything that I should go over again? Well, again, if the linked list is empty, right? So in that case, it's the first one. We want to make the head and the tail not be no anymore, but we want to have them be equal to whatever n is. So let's say, so this is our linked list at first. It's no, but then we're saying add something like add 1, and then we're making, well, that's really what is when we say add 1, and before that it was empty. And then this will be head, and then it will be also the tail. Then when we say another, let's say add 2, right, then it would look like 1, 2, and this would be of course pointing to no. Now let's go up to our code and see how is that working. Well, it's not the linked list is not empty anymore because there is an element there. So then we're saying temporary head be equal to head. So this would be the temporary head here in this case. And then what are we saying? Well, while the next is not no, so this is not no, right? It's 2, so it is a node. So since it is not no, we want to move the temporary head to there. So now, instead of the temporary head being set as 1, like this, it is instead going to be here. Temporary head. And now if we go back, you see, while the temporary head next is not no, well, now next is no, right? It is no, so it will stop from there. And then we're saying make the temporary head next, which is the no, be equal to whatever the n is. So let's say in this case 1 was pointing to no, but then we said make the next, which is the no, point to whatever we're adding, which is 2, right? So now instead of pointing to no, 1 is pointing to 2, and then by default 2 is pointing to no, because that's how we implemented our node. Because node next, we're not setting it to anything, which means it's just going to be no. Alright, so hopefully that makes sense, guys. If you have any questions, then ask me in the comments. I'll be happy to help you. But anyway, so yeah, the next video is going to be again concentrated on linked list, more specifically removing the duplicates. So thank you guys for watching, and see you on the next video.